got here water and wood. This is one that's kind of like mixing water and oil. It's really understanding of what we can and cannot do with materials when we look at hydroscopic materials. When we start looking at a wood manufacturer, every manufacturer will have their specific requirements, whether it's, you're looking at the range must be 60 to 80 degrees and relative humidity between 35 and 55%. Typically your 35 to 55% is, for the most part, a US standard. When you start getting into your 40 to 60%, a lot of times you'll see like your European oak, a lot of your Asian material, they'll be up on the 40 to 60% range. Then you look at the substrate, between the floor and the substrate must be within 2% of relative humidity of each other. But when you look at the environmental conditions and the specifications of your pre-installation, the requirements should be maintained for the life of the product. So when we start to get, I just got back from Jersey, and we had a floor in there that it blew up in 6 weeks. And when we went out there and did my inspection, they just finished doing the color prime on the walls. Okay? They're one block off the water. I did my historical checking for those 6 weeks. We had an average relative humidity outdoors of 83%. Can you imagine what the construction site was like for those 6 weeks while a tile setter and everybody else were still in there doing taping? And so therefore it's really getting back to is we must, when we're looking at it, putting floors in, that the environmental site must be, and looking at it, having it as in a controlled environment, humidity regardless of species or thickness, the parameters must be followed for temperature and relative humidity. That floor, the day I was here doing my inspection, I've done install for 40 some years. I walked in that house and I'm going, today is the day this floor should be going in, not 6 weeks ago. And then they wonder why, well, manufacturer related, they're going, you're pushing bullets the wrong direction, because it really falls on who is in control of the job site and getting the materials out there prematurely. So when we start looking at ranges, for example, here you look at your wood flooring is brought into equilibrium before installation. This is just an average chart that came off of NWFA, and you look at, well, the average for our area is about 8% or somewhere in this 40 to 45% relative humidity. When we start looking at like microclimate areas, for example, if we were a contractor in San Francisco, you're looking at moisture content ranges here at 11% on coastal, move 50 miles inward, and you're down to that 8% range. So, my sister lives inland, but I want to have this floor. Well, those two floors are not going to perform equally in one in a microclimate like off of San Francisco. So 50 miles in, you're seeing that the average RH in there is around 63% with an 11% moisture content. So if we're dealing with a product that's 35% in requirement, we know we're guaranteed failure for that. So, being like in design and looking at it as far as selection process, we must understand geographically what area we're in, but then also what it gets into as far as in our own microclimate in the house, as far as moisture control systems. So here we got in acclimation. When you look at here is the process is adjusting the wood flooring to the moisture levels of its environment. You're also going to say is, a lot of times you'll see some manufacturers will being able to want to take, for example, if we have an engineered package, and they tell you, hey, let's do this. Let's open the ends of the packages. Now, ask yourself a reasonable question. On this banana, if I'm going to equilibrate the moisture of this building in the core of this banana, how long is it going to take by just going through the end?
A long time.
I have to peel the whole banana. The same thing that happens is when we start looking at is having the environmental change and having it as a product. The product in this bag was manufactured to stay dry. It's only going to change when I open this package up. For example, like if we had a job site that's say 45% relative humidity, there'd be no real requirement to acclimate this product. But if we have this same package of pretzels or taking of potato chips and putting them down in Miami, and I open this up for 3 hours and put it on the counter, how good are these chips going to be? That's going to suck water to them. The moment this bag is opened, those chips are going to start taking on moisture from Miami. It's the same thing when we take engineered flooring and bringing it out to a job site that's got, like the one in Jersey, 80% relative humidity, and it's doing for 6 weeks. The minute that the box is opened, we're in a bad environment, and that thing is sucking up water until the day, and that's where it'll reach. Like it says, it will take on moisture from the air forever. This is a thing we're guaranteed that'll happen. Our position is to make sure we have guaranteed air. So when we ask here, now this is one I did, one in Chicago. And we had here, you look at the time of install, we had 32 rows, and they measure 128 inches. Okay? 2 weeks after install, look how much that floor grew. 3/8 of an inch. Now, in what's going to happen, when that floor finally reaches its equilibrium and comes back into sync with the normal climatic conditions, we're going to have, in that 128 inches, we're going to have 3/8 gapping somewhere in that system, which is going to be unacceptable by the consumer. So in turn is the importance of making sure that not only through our installation practice of having and making sure that we've got climatic controls, but to ensure that the builder does after. So that's what we talked earlier about having importance of having installation documentation from that time. And we're going to get into that a little bit farther, but just to show you what 2 weeks can do of moving that floor 3/8 of an inch. So when we get the simple chart, many of you have seen this before, but when we start asking about equilibrium moisture content based off of temperature and relative humidity. And in that we can take, for example, this is the range that a solid, unfinished American species material prefers to be in. We've got 60 to 80 degrees and 30 to 50% relative humidity. Now, in a pre-finished site product, they may be from 35% to 55%, so they'd be in here to 7 to 10% moisture content. When the wood is cycling from winter to summer, and we talked on far as that 128 inches with that 3/8 growth in it. In the winter, and that comes back to our 6% moisture content, and that would be your 30% relative humidity, that it's going to show those gapping of those 3/8 of an inch. It's going to show up somewhere. And that's why it's really critical to see on where they were well over their 9% mark on their wood. But when this comes back, it's always going to show that the wood will travel at whatever the level, the temperature and relative humidity, it will bring a equilibrium of that moisture content. So it's easy to predict, as we saw earlier in Gary Bittner's material of showing on when we start looking at predictability of wood movement. All we have to do is predict the environmental control, and we got pretty much what that wood's going to do every single day. All we have to do is identify what the control is.